Welcome to The Explainer. Today, we're going to completely reframe how you work with AI. We're moving way beyond basic prompts, and instead, we're focusing entirely on the step-by-step systems, the hardware, and the specific blueprints you actually need to build complex, production-ready software. Think about that quote for a second. Being a senior engineer really means being an architect, right? It requires meticulous planning long before your AI builder ever writes a single line of code. Top-tier engineers spend weeks writing design documents before any typing begins. And AI didn't invent this discipline. It just made it the absolute most important skill in the room. And this creates a massive divide in the industry right now. On one side, you have reactive vibe coding. Sure, it's fine for a quick weekend phototype, but the moment your project actually scales, it collapses. You add a new feature, and it instantly breaks an old one. To stop your AI from drifting, you've got to embrace predictable, spec-driven development, where the AI executes against a rigorous, predefined system. So here's our blueprint for today. We'll start with the AI architecture mindset, move into the 6-file context system, explore full-stack systems architecture, dive into the spec-driven development process, and finally wrap up with optimizing the execution loop. All right, Section 1, the AI architecture mindset, moving from typist to architect. Before the AI touches anything at all, you need to map out your application conceptually. You really have to master these 3 phases of schema modeling. First up is the conceptual data model. This is where you map out business logic, like, say, a member borrowing a book without even worrying about the tech stack. Next is the logical data model, where you define primary keys and relationships completely independent of a specific database. And finally, the physical data model. That's where you apply platform constraints, specific data types, and performance indexes. You absolutely have to do this thinking first. Moving on to Section 2, the 6-file context system. This is essentially the cure for AI memory loss. So instead of starting with a blank page, you externalize your entire architecture into a master blueprint made of 6 context files. Living right in the root of your project, these files give the AI your core user flows, tech stack boundaries, strict TypeScript conventions, and your exact UI color palette. Building this context is step 1, ensuring the agent knows your codebase intimately before a single prompt is ever fired. But the real secret weapon here is the progress tracker. We all know AI agents inherently lack memory between sessions, right? Well, by requiring the AI to read and update this specific file at the start and end of every single task, you completely cure its amnesia. It instantly knows exactly what was just built and what needs to happen next. It's a total game changer. Let's jump into Section 3, Full Stack Systems Architecture, the tech stack layer cake. You must define this full stack layer cake explicitly step by step. If you don't tell the AI you're using live blocks for your real-time canvas, it might just waste tokens inventing a custom WebSocket implementation from scratch. By outlining Clerk for identity, Trigger.dev for background tasks, and Vercel Blob to keep large artifacts out of your Postgres database, your AI agent transforms into a highly disciplined implementation engine. Now, great AI development also requires physical hardware mastery. When you're testing complex databases locally, you've got to constrain your local virtualization. By configuring a global .wsl config file, you prevent Docker and your databases from completely starving your host operating system. Capping those container allocations to roughly 50% of your host RAM keeps everything running flawlessly. And to prevent thread exhaustion when you scale, you need to use a strict physical core formula to size your database connection pool. It's simple. Pool size equals the number of physical CPU cores multiplied by 2 plus 1. Route your queries through PG Bouncer sized with this exact formula, and your PostgreSQL database will easily handle heavy AI-generated traffic. For true production-grade resilience, you also want to instruct the AI to build out PostgreSQL wall streaming. That stands for write-ahead logging. It ensures changes are written sequentially to a log before the actual data files. Streaming these records to standby replicas creates a highly available, crash-resistant architecture that instantly recovers if a primary node happens to go down. All right, Section 4, Spec-Driven Development Process, executing the blueprint. With our database optimized and context layers built, it's time to feed instructions to the engine. But we've all been there, right? You ask the AI to add one new feature, and suddenly it rewrites your navigation bar and completely breaks your authentication flow. So how do we stop this from happening? The answer is a rhythmic, highly disciplined execution loop.
Step 1. For every single feature, you write a dedicated spec file defining the exact goal, the UI constraints, and a strict checklist for what constitutes done. Step 2. Tell the agent to read the spec and update the tracker. Step 3. The agent builds that one single focused unit. And Step 4. You verify it against the checklist, merge it, and move on.
Finally, Section 5. Optimizing the execution loop. Let's look at beating those platform limits. When your app is generating AI content for users, analyzing complex architectures or massive documents takes minutes. You literally cannot use standard API routes for this. They'll just time out and fail. Instead, you must instruct your AI to offload that heavy lifting to durable background tasks using tools like trigger.dev. This runs safely in the background, streaming real-time status updates back to the user without ever blocking your front-end UI. Also, when your AI generates complex structured data, relying on standard text output often results in broken schemas. It's super frustrating. By utilizing strict tool calling, you actually force the AI to interact through named functions. This entirely prevents runtime schema errors and keeps the agent perfectly aligned with your architecture. So, bringing it all together. By combining strict hardware resource limits, that step-by-step 6-file context system, and the rigorous discipline of spec-driven development, you fundamentally change your role. You stop typing. You stop fighting the AI. You stay the architect. Think about the immense scale of what you can create when a highly disciplined system does all the heavy lifting for you. You now have the blueprint to master AI-assisted architecture. So the only question left to ask is, what will you build now that you are the architect?